Hello, everybody. Bonjour, bonsoir, buongiorno, buonasera, buonanotte, maybe good morning. I don't know where you are. We're extremely happy to have this online meetup between two European chapters, Paris and Milan. And it was a joint effort. And we're extremely happy that we are welcoming you today. Because Zoom is new to some of you and less to some of you, let's start with very simple online code of conduct. So first of all, please switch off video to save bandwidth, because it's most important to have good sound and then good screen. Please mute your microphone when you don't speak. But when the moderator asks you to speak, please unmute your microphone and speak. If you want to ask a question, you can use chat, you can raise your hand in chat, and you can use smiley and emoticons for better understanding. And if something happens that you get disconnected, just please simply calmly reconnect. Now let's start with a reminder of what is WiMLDS. Maybe some of you don't know yet. It's a global organization whose mission is to support and promote women and gender minorities who are practicing, actively studying, or just interested in machine learning and data science. We are a very open organization from this point of view, and the principle is very simple. It's always women who speak, but the attendance is open to any gender. It's a big organization. There are more than 50,000 members worldwide, spread out throughout the world. And the whole organization adopted a code of conduct, which is, let's remind to ourselves that it's a harassment-free environment. It should be nice. We should not make any comments that wouldn't be inappropriate. Now, this meetup is brought to you by two chapters, WiMLDS Milan and WiMLDS Paris, and I give the floor to Carlotta, who will introduce the Milan chapter. Let's deal with the technology first. Marie, can we make Carlotta the presenter or the speaker?
Yeah, I think she just has to share her screen.
Yeah,
okay.
If you want, Natalie, if you want to continue to share your own screen, I can talk.
Okay, okay, let me continue share my screen then.
While Natalie is sharing again the screen, first of all, I would like to thank Natalie, Carolyn, and all women in machine learning and data science Paris for being the promoter of these events. It is indeed a real pleasure for us to be here tonight. And we would like to think of these as the first of a series of jointly organized events. The Milan chapter was founded by Claudia Volpetti and me, and is a little younger since we were born 2 years ago. And it is the only Italian chapter that has been opened so far, even if we do believe that similar other initiatives will be started soon in our country. The activity of the Milan chapter in these months mainly revolved around the organization of thematic events, each usually addressing a specific topic in the machine learning and the data science domain, as well as of hands-on sessions. And I think that we can say that all of these events gave the members the opportunity of deepening their knowledge, enriching their networks, and sometimes also practicing themselves with these kind of topics. Starting from the very first event, we experienced a rapid growth of our community, but let me say above all, we really felt a great enthusiasm coming from both the members and the different organizations and companies which kindly hosted our events. And on the way of this enthusiasm, we already planned novel meetups. We hope we are able to propose in the original forms that is in presence as soon as social safety and health conditions will be somehow restored. Let me also add that in the last few months, we were glad to observe that more and more often companies desire to know more about the women in machine learning and data science community. They desire to get in touch with it with the aim of promoting their open job positions and of course of recruiting talented data scientists and machine learners. And we are really proud to act as a means through which our members and companies can connect for professional purposes. So to conclude, I would like to remind that for this reason, we opened a section on our Meetup page that I invite all the attendees to visit, which is specifically devoted to these open job opportunities. Thank you, Natalie. Thank you for inviting us at these events. And I don't want to steal time from the speakers, and I leave you the floor for the forthcoming very, very interesting talks.
Thank you very much. So I will briefly introduce the Paris chapter. Here we are. You see Chloé Agathe and Caroline, Chloé Agathe Azincourt and Caroline Xavier, who are two co-founders. Marie Saksik in the middle, and that's me, Natalie Chernetska, in the side. So we are 4 in the current team. The chapter started in August 2017, and we organize meetups and also paper reading sessions. Now, for the time being, all the events are online, so we're extremely happy to do this event with the Milan session, and I hope that we'll have more sessions with different European and perhaps beyond chapters. And who knows, maybe one day when the situation will normalize and we will be able to meet again, we can organize a big European conference in presence in some beautiful location, for example, in Italy. So that's about the team. And obviously you can follow us and the Milan chapter on Twitter. We share all kind of information about our events, but also about women and gender minorities in data science. You also can follow both us and the Milan chapter on LinkedIn. There is a Slack, there is Instagram, there is website, and on the website also organizations can post their job offerings. So if you want to get in touch, there's really a variety of ways of doing so. And for tonight, we have a wonderful agenda with 2 speakers, 2 amazing data professionals, one representing the Milan chapter and another representing the Paris chapter, although they both are Italian. So today we really have an event with a beautiful Italian accent. We are going to have Valentina Franzoni talking about emotion recognition and artificial intelligence. And then we'll have Chiara Biscaro talking about forecasting affluence in supermarkets during lockdown. So let's begin. You can tweet about the event. There are several hashtags, WiMLDS Milan and WiMLDS Paris. And now, I think without further ado, I will give the floor and the screen to Valentina, who will introduce herself and will start her talk. Valentina, the floor is yours. Let's hope the technology works. Let's try to figure out how it can.
I hope that technology will work.
It works, right.
Otherwise, for a computer scientist, it's very bad.
So that, on some conferences about artificial intelligence, people cannot figure out how the microphone works. I think we'll better.
It's true.
But please bear with us. We just figure out how to reshare the screen. So,
take control of the screen.
Host, and actually you can start sharing.
I think that you're already seeing my
you are
slide. Perfect. So I am Valentina Franzoni from Department of Mathematics and Computer Science of University of Perugia, Italy. I will speak on emotion recognition in artificial intelligence because it's my main topic of research and I love to share ideas about it. So what I will show you in this presentation will be not very technical, but of course you can then ask to go more in depth if you like it. So the seminar overview is this. You can see in the slide, but I will introduce what is artificial intelligence approach to emotions. What is an emotion, first of all, and then some approaches related to machine learning and data science. And then I will speak about errors, bias, and overconfidence in already existent artificial emotional models. So the usual errors that scientists do when approaching to emotion recognition. And then I will propose you, if I have time, some open challenges. So let's start with emotions and artificial intelligence.
Excuse me, Valentina.
Yes?
Hi, this is Caroline speaking. We cannot see your slides.
We cannot see your slide, and I'm trying to figure out what it's all me, perhaps. Do you see there is a green button?
I see the screen with the green,
and the members are not seeing it either, so I prefer to stop you in order to fix that, and then you can go on.
Let's start again.
Right.
So you say share screen at the green button, and when you click it, it should be working.
So what you can see now?
We just see general Zoom meeting.
You don't see my desktop?
Mm-mm.
I don't like about computer science. Let me try another time. Okay.
Right. Now, yes. Excellent. Wonderful.
Everybody can see it now?
Yes, beautiful picture. Thank you so much.
So this is my slide. Can you see it?
Yes, emotional recognition and artificial intelligence.
Perfect. Let's go on.
Thank you.
So let's start with emotion and artificial intelligence. So first of all, I want to give you some questions instead of giving you answers. And research questions about emotion recognition are: what are emotions? How can they be measured in the brain? How can they be measured in their expression of our body, for example? How can they be represented in computer science? And if they can be recognized using artificial intelligence or web intelligence. So, starting from what is an emotion? Our decision system in our brain is composed of two phases. There is a cognitive system and an emotional limbic system, which are separate in our brain, having a different input. So the brain decision output is a combination of the two. In some situations, one overcomes the other. For example, let's take this situation. If I see this lion that you can see in the photo, so my cognitive system will just say, there is a baby lion, maybe the mother is around. My emotional system will say, oh, how cute, I would like to touch it. What will be my final decision? My decision will be, it's better to watch it from far, because in this case, the cognitive system, you see it bigger, written in a bigger size, the cognitive system will prevail on my final decision. Instead, in this other situation, I will also have lions, but these can be aggressive lions. My cognitive system will say, lions are running at me. And my emotional system will say, fear of death, run away. So the final decision will be to switch on our emergency state, which is residing in one part of our brain. So instead of combining the input from the cognitive and emotional systems, in this case, we execute only the emotional system in the emergency state as fast as possible without thinking about it. So the cognitive system in humans is what separates us from the animal kingdom, while the limbic system is the same of animals. It is older than the cognitive system and is pretty basic. So emotions are something that get us to act in a particular way after taking a decision. And the feeling that we have in our emotion is not needed, for example, to run if I have a lion in front of me, but is needed to teach and plan for the future, because my emotional experience will be something that I maintain in my brain and from which I can learn. And in this part, the cognitive system will interact. So it's the internal subjective component of the sense of perception arising from the stimulation, the triggering of the senses by an external phenomenon. Then, in AI perspective, in artificial intelligence, we can give some definitions of what are emotions, how can emotions be approached. First of all, emotions are very basic, and so they are primitives. And they are also modular, because more than one emotion can act in my brain at the same time. They are fast and they are approximated, because we saw that in some situations the cognitive system will not interact at all. And so the final decision will not be for sure the best one, but there is an approximate decision. And they are reactive because they are executed automatically and very fast. They are based on the environment, and so they can be defined adaptive. They are evolutionary because they are temporary and sometimes with the learning. For example, in the case in which one of my emotions will teach me something about how to act in the future. And they also can be collective and contagious because, for example, if I am in a crowd and I see panic in the crowd, I will panic myself, even without knowing what is the trigger of the panic. And so they are contagious and collective. One important thing to say about emotion recognition is that emotions in an AI perspective are not the usual feelings or the thoughts. The thoughts will be of the cognitive system, not of the emotional system. And they are not only sentiments. So, for example, a trivial sentiment analysis is not the same of emotion recognition. And they are not moods because they are related to what is called in biology an emotion, which is what triggers a particular part of our brain. Then, said it, we can go on to machine learning and data science approaches. I will just show you some previous workshops topics that we had with applications of emotion recognition. For example, in this seminar that we had with the University of Hong Kong, we had this very interesting talk about deep learning image recognition. In this case with TensorFlow, but we can do this kind of image recognition with many different methods. So in this case, you can see that the software was able to recognize the emotion on the face expression of a person, of a user, basing on some particular movements of the brows, of the eyes, and of the mouth and cheeks. Okay, so with an instrument very easy to use like TensorFlow, we can do this kind of emotion recognition on a face. Then we can also do something more, because face recognition is very easy to implement. But we can also recognize emotions by full body expressive movement. Just think about somebody dancing, how they can express very easily an emotion. And so we can also recognize the emotion looking at the movement of the whole body. This is related, of course, also to gestures. For example, you will know probably that in Italy, we make a lot of gestures when we talk. And if we are angry, we will use different gestures with respect to when we are happy, for example. And so we can recognize emotions also from the expressive movement of the body. But we can also recognize emotions from text. For example, there is this method that maybe I will show you later in depth, that is based on semantic emotion recognition. So, looking at the semantics of a word and of the semantics of the words expressing emotions, we can see how similar they are. For example, if you see in the slide, we have the word kill, and we have an emotion model. In this case, it's the Ekman model with anger, surprise, sadness, joy, fear, and disgust. The similarity of the word kill will be higher to anger, to disgust, to fear, and lower to joy. And this is made by web-based semantics. What does it mean? It means that I will look on the web and see, for example, in Google or another research tool, and see how many times these words can appear together on the web. So if they appear together a lot of times, they probably will pertain to the same context. The same approach to text analytics for emotion recognition can also be done, for example, on social media or for many different goals like opinion mining, not only emotion recognition itself. And this can be applied to many domains, for example, to the domain of food, because also food can trigger emotions in us, in humans. To understand which different applications we can have, of course, we have to know something about the neurophysiology of emotions. So we have to study which part of the brain is interacting in different emotions. And the interesting and beautiful thing is that, as you see in these very little human pictures, every emotion will be involved in reaction of our neurophysiology in different parts of the body. For example, we know that when we fear something, we will probably feel it in our stomach, while if we are angry, we will probably feel it in our head, or we will feel hot. So we have different manifestations in the body, in our neurophysiology, and this can be tracked with some specific tools. So we can do emotion recognition also using some particular tools, for example, to measure the hydration of the skin, or other tools that can track these particular manifestations of the physical emotions. And then another very important fact to know is that emotions are related to mirror neurons. Mirror neurons are some neurons which have been discovered a few decades ago, in the second half of last century. And they say, this theory says that we interact with others, communicating with a sort of mimicking of the other's expression. And this happens because the small babies, when they are born, will learn how to recognize themselves and the others, and then how to recognize emotions of the others for empathy, just looking at the face of the mother and of the father. So, for example, in this picture, we have that the baby is mimicking the expression of the father, which is, in this case, the scientist. And the very incredible fact about mirror neurons is not only that an expression, so also an emotion expressed by the face of another person can make us feel the same feelings and so the same emotion. But also there is the opposite. So if we simulate a facial expression, the mirror neurons will send to the brain, so also to the limbic system who cares about emotions, the feeling that is related to that expression. So if we smile, we will feel the same that if the smile is triggered by something external. If we fake an anger expression or a sad expression, for example, we pretend to cry, we will feel inside our body, of course, not the exact same of the case in which we felt in the real world the emotion, but we feel something similar because the insula and the limbic system will be triggered by this facial expression that we are doing. So we can stimulate, we can trigger in part the emotions just offering a face or simulating the facial expressions. So this can be a very broad application field, using, first of all, understanding and then using the mirror neurons. But one and the last thing that I want to tell about possible studies about emotion recognition using artificial intelligence is maybe the most important, that we can do everything with an ethical approach. Because emotions can be used for hacking the brain. And we don't want to hack the brain, for example, for bad purposes or without the person understanding what we are doing. Now let's see a bit more in depth two of the methods that I showed. I hope I will not be too much technical in this part, but I promise it will be very short. So the general idea of the web-based proximity models, as I introduced, is to use search engines as a source of information about the frequency, so also the probability of terms, for example, in the Google page counts. So the probability of a word can be calculated as the frequency of the word over the number of the indexed pages. And there are some tools that let us know how many pages a web search engine is indexing. But even if we don't know the total number of pages, the important is, since this is a normalization, is that we use a number which is not smaller of any possible result that we have in our study. So using this probability, we can understand how many times a word, for example, gatto, which is the Italian for cat, will appear together with other words. And if we do it also for pairs of words, not only on one word at a time, but also for two words, so for the two words that we want to track for the similarity, we can obtain using many different measures like PMI or these other ones, confidence, normalized Google distance, and so on. We can know how much similar the two words are. So in this approach, we will have a model of emotions which includes some words expressing the emotions. Of course, the words will be in a particular language, so we can have some differences from one language to the other, especially if there are some languages that are not well indexed in search engines. But let's look at English, because English is for sure functional in this case. So, for example, I take the Ekman model, which lists this emotion that we already saw: anger, disgust, fear, joy, sadness, and surprise. And then we will have one word. So this word can carry some emotional meaning, even if it is not expressing directly an emotion. As we saw, the word kill can raise in us some emotions, and these emotions are the same, that are more similar as words to the emotions in the web. If I have not only one word, but a lot of words, for example, if I have a sentence, I can do the same. I can track the similarity of each word to the emotional words. For example, this gunman killed Iraq raid. Gunman killed in an Iraq raid was the title of a newspaper. So we can filter the words. We can take each word and look in a search engine how many times it happens, and then how many times it is indexed together with each one of the emotional words. And so I can track the similarity of each one of the words of my sentence to each one of the emotional words of my emotional model. And then I can do an average, or I just can take the maximum to understand the emotional meaning of the whole sentence. So in this case, I had gunman, which raised disgust and sadness, kill, which raised anger, sadness, disgust and fear more than others. Then I had Iraq, which during the war was related to anger, fear, and to surprise, and then raid, to surprise, sadness, and fear. So in this case, I can calculate which of the emotional word is prevalent for the whole sentence, and so I can say that this sentence raises that emotion. Of course, I can also choose more than one emotion, but since in this model there are only 6, it's good to choose 1 or 2, not more. If I choose a different emotional model, of course I can do different choice. So this is just to recap how this algorithm works. I will have my text resource, and then I will do some natural language processing with the tokenization, stop word removal, and filtering all the words that cannot bring an emotional meaning. And then I will give the terms to my evaluation engine, which will look at the search engine and then will do, for example, with an USM using many different methods, is the same, can do the emotion tracking of each word, of each term T, and then with the emotion aggregation, which will be or the maximum or the average, will get the ranking of the top K emotions of the sentence, and then give me the final object emotion ranking. So the other method is the very easygoing method of face recognition. Why easygoing? Because there are many, many tools that are available online, and so that we can use to recognize emotions with a few programming skills, let's say. So looking again at the Ekman emotions, so only 6 emotions, and in this case we added a neutral instead of surprise, we can fine-tune a neural network. So the best approach that I can share with you is to use a pre-trained neural network, for example, the very well-known GoogleNet or AlexNet, that are trained with a very high number of images, and so will let the final neural network recognize very easily all the features of low level that are related to images, for example, the shape, the color distribution, and so on. And then do a fine-tuning of the network with a set of images related to emotions. And then, of course, save the final network. So with this network, even with not very high number, so with let's say few hundreds of training images for the emotions, you will have a very high precision and accuracy of the final emotion recognition. If you do it on one single user, it will be very precise. Otherwise, it will be more general. And this works also on dogs. And we made preliminary work also on dogs. So CNNs are a very good tool, but not the only one to use deep learning for emotion recognition. And as I said, we used in these 2 examples the Ekman model, but our emotional models can include many, many other features. For example, we can use together the facial expression and the word used, or the body language, voice characteristic, or all the other things that we already said, that we can track, that we can measure. So an interesting application that I want to show you, just to let you understand the power of emotion recognition, is this one. So in this case, we had a scientist tracking the voice of Mark Zuckerberg and Steve Jobs. We all know that Steve Jobs was very charismatic, okay? So they tested putting an acoustic voice, so something that is not recognizable as the voice of Mark or of Steve, putting it in a car tool for the navigation, okay, in a car navigator. And there were 30 drivers of the university in which was made this research that were knowing very well where their university was located. But instead of going on the shortest path to the university, the car navigator suggested wrong path. And many of the people followed the wrong path if the features of the voice were similar to the one of Steve Jobs. Instead, only a few followed the wrong path with the voice similar to Mark Zuckerberg. So, these are the final results. This can let us understand how powerful it is to use a particular charismatic voice, triggering particular emotions in us, using the frequency, the prosody of the speech, because this can touch us in our inside, touching some parts of our brain, letting us convince of something that is very different from the truth. So, looking at some error and overconfidence, I want to show you some bad use of emotion recognition. So first of all, we already told that it's different from sentiment analysis because different parts of our brain are involved. So don't ever say that you are doing emotion recognition if you are doing only sentiment analysis, which happens a lot of times. Emotions are a lot, okay, and are not only feelings, not thoughts, not moods, and not related directly to the cognitive system. Sometimes we also face some overestimation of the benefits of emotional machines, because not always it's good or useful to have emotions in a machine, okay? And many times we see applications that are good from technical side, but with no particular useful goal. And then there can be an overconfidence in assuming the emotional nature of a machine. It's not simply naming an emotion with an if-then instruction. If I show this expression, then this is an emotion, because the machine is not expressing an emotion, okay? So an emotion is something that can be on humans or can raise something in the humans. It's not only mimicking or faking an emotion. I already talked about this application, so let's go on. Another usual mistake is the duplication of the concepts, reinventing the wheel. There are many already existent libraries and methods, for example, for emotion recognition from the face. So why to create another one from scratch? It's better if we focus, for example, on recognizing only one part of the face, or anyway doing something that is not already done. Another mistake is the oversimplification of human emotions. For example, the Ekman model, which was also used in this movie, is the first maybe to state the basic emotions, the main basic emotions, but there are a lot of other models, more complex and more real. We can state from science that human emotion can list more than 130 variations, and so it will be good to explore them. The two errors are to think that our experiments will be valid for everybody all over the world. It's not true, because in expressing emotions, there are differences in different cultures. For example, in Italy, in Europe, also in America, the facial expressions are different from many Asian cultures, or African culture, or South American cultures. There are some tribes where they don't use at all, for example, the mouth to express emotions, but only the eyes. So if our experiments are made on a particular culture, we cannot state that we can recognize everybody. And another mistake is to use gendered models, because emotions can have differences in female or males, but that difference usually is not used for something that adds a value, but just to take some expressions, cultural expressions that we don't want to portray in the time. For example, that assistants should be female. Why assistants should be female? Because in the history, it was the female to do the lower level tasks. And we don't want to keep this kind of approach. So, which are the open challenges? For sure, all the ethical applications. For example, the emotional intelligence, which is made up of these 4 skills: self-awareness, self-management, social awareness, and relationship. So we can help all these applications with the use of emotion recognition. And emotion recognition can be used also for self-aid. So I can use, for example, face recognition or text recognition to understand which emotion I am expressing, maybe without understanding it. Some applications in this case can be, for example, for dependencies treatment. We know that in facing alcoholism, workaholism, or sexaholism, we will have to do a step of 10 steps, which is to understand our particular emotions. So if I have a tool, for example, like a mirror in which I can look myself in the morning, and that can recognize my emotion day by day, it can be useful to help me for my dependencies. Then for nonviolent communication, for people in leading roles, for example, a professor sending an email to a student, maybe he or she will use some words that can have a violent meaning, too strong words, without understanding it. So a tool for emotion recognition may analyze the email and report to the user these meanings before he or she will send the email. And then at last for empathy learning. So for parents or teachers, for example, in the circle of security care environment, which is made of a particular model of emotion and caring, parent caring, where they analyze videos of interaction of parents and childs, or of teachers and childs, and an automatic tool may help to recognize the emotion of the child facing some particular situations. I want to insist on the ethical goals, because emotions analysis can easily be misused for unethical purposes, such as controlling people's emotion to influence their commercial or even worse, their political choices. And in my vision, the research of emotion recognition and affective computing should be informed by ethical principles and facing ethical goals. And emotion recognition deeply involves the user intimate beliefs and states, which sometimes are even unknown to the same user, who can be unaware of his or her emotional state. So researchers entering in such domains should consider and reflect on their own research goals in order to avoid creating methods that can be misused for unethical goals. A guideline, in my opinion, should be to find practical applications to help human beings to live better, especially researchers from university who are paid even if they don't have a product that can be sold. So the same is approachable, for instance, improving the management and the consciousness of the emotions in order to choose the appropriate behavior with application, helping to, for example, who has short availability of funding, so with a cheap application, or inventing aids for the weakest, for elders, for people with disabilities, people with physical or psychological pathologies, to support helping to diminish pain in hospital, for example, recognizing pain from the expression of the face and providing support for who is suffering. So a general algorithm for all these ethical applications that I listed may be to classify emotion from a sensor data, which can be also a camera, for example, for the video, then ranking the relevance of the detected emotions concerning the application goal and the context, of course, of application, and then projecting the consequence of the emotion concerning a specific model of affective computing. And then eventually at the end, triggering a user emotional feedback. For example, as I told, in order to call for a self-aid action, if the detected emotion appears to affect the application goals. So this is a very trivial system architecture where the emotional status feedback module will be in charge of generating the appropriate emotional affordances to draw the user attention on the message. With the speech behavior, tracking of gestures or acts which can potentially represent a danger, for example, for a relationship, like in violent communication, with a single person or with many communication partners. And then the contextual information can vary, of course, depending on the application domain, and they can be represented with simple contextual information or with more complex data extracted with artificial intelligence tools, for example, by documents, messages, videos, and so on. And the idea is that although their emotions are deeply analyzed, the users are not substituted by the tool, but only supported in their final decision. So the system has only the role of highlighting the emotional content and the consequences of the user behavior, either respect to themselves in the self-aid or to others in violent communication and so on. So in a typical self-aid application, the user feedbacks can range from a simple hint, like a meme or a danger sign, to casual explanation, for instance, a graphic chain of the emotional interaction with other subjects. So this is the end of my speech. If you want to start mastering emotion recognition, or if you have any collaboration proposal or other questions, then what you can do now. These are all my contacts.
Thank you very much, Valentina, for this fascinating talk. It's really fascinating what can be done on the intersection of many fields, such as neuroscience, psychology, machine learning, etc. It was very interesting, and I'm sure our audience have a lot of questions, but we are really running out of time. So what I suggest that we are going to give the floor to our second speaker. And Valentina, perhaps you can stop sharing your screen. And the audience who has a question for Valentina will keep it, and we'll have a Q&A session at the end. So now our second speaker is Chiara Biscaro, and Chiara is going to share your screen.
Yeah.
Already
can you see the screen?
Forecasting affluence, yes.
Great.
You start present, and that probably will work. Excellent.
It works?
Right. So I will just say that Chiara is senior data scientist in Google AI Lab, and she was one of the co-organizers of Paris WiMLDS Meetup several years ago, and we are extremely happy to have her speaking here. The floor is yours, Chiara.
Thanks, Natalie. Yes, so hello everyone, I'm Chiara, senior data scientist at the Carrefour Google AI Lab. Before I start, some quick word about myself, because people always think my background is, how do you say, a bit strange. So I started my career in astrophysics. So I left Italy in 2010 to study theoretical physics in Basel, where I did my PhD studying this supernova here. You can see the picture is called Cassiopeia. And then after my PhD, I left for a postdoc, again in theoretical physics or astrophysics at the University of Copenhagen. You can see the nice gender diversity, by the way, in this kind of group. Physics has a problem too in this regard. And the point here, there is no machine learning or computer science anywhere. So my background has actually no machine learning or data science at all. What I did was, when I wanted to switch from academia, I did a boot camp in London that is specifically for people with a theoretical PhD that want to switch to data science. And this boot camp let me get in contact with Caroline, that at the time was working at Criteo. I passed the interview at Criteo, and I joined Criteo Paris as a software engineer in R&D. And at the time, I didn't speak a sole word of French, so it was a bit, how do you say, complicated coming to Paris. Now I speak some French, still not enough, but let's say now it goes a bit better. I stayed at Criteo for almost 3 years, and September last year, I joined the Carrefour Google AI Lab. This is my cat, by the way. So as Valentina told us in the previous meeting, maybe now your the emotional part of your brain should tell you how cute. That's the people in the lab. The Carrefour AI Lab has been founded almost a bit more than 1 year ago. And the point of the lab is to address all the problems that can arise at Carrefour regarding stores, supply chain, with data and ML. And apart from ML, we all know, sadly, that 2020 brought us some guests nobody was expecting. So for the non-Italians here, this is a comic from Leo Ortolani. And the guy here is saying, to the coronavirus. Look, on the 4th of May, we all go out. Why don't you come too? And the virus is like, oh, that would be nice, but I don't know anyone. The guy say, oh, don't worry, I will present you, I will introduce you to everyone. You just need to shake their hands. So yes, we still have this virus, and as soon as the virus started to present itself, the government started reacting in various countries, and this impacted in a quite sharp way how people make their shopping, especially for us at Carrefour, the grocery shopping. As this plot, you can see this plot for various countries, Italy, Romania, France, because Carrefour is present in various countries. It shows you how the transactions are impacted compared to last year. So the curves will tell you what's the difference of the transaction this year versus last year. And you can see January and February, you have some noise. People are usually quite regular in the way they do their shopping. If somebody wants to go on Friday afternoon, they will always go Friday afternoon. But here, the coronavirus starts. So this first blue bar is when Italy first started to close shops and school. And you can see that the Italy curves react when people run into the shop. This blue bar in the middle is when the lockdown in Italy was announced, and you can see the curve of Italy jumping again. And this other bar here is when the lockdown in France was announced, and the French people are the one panicking the most because everybody just ran to the shop to stock up on toilet paper and flour and eggs because we are in France. So we need to stock up for our crepe. And this caused quite a lot of problems because the stores were assaulted, and this virus, it's important not to have people conglomerating all together in the same place at the same time. And our supermarket director were quite at a loss because they didn't know how to inform people not to come at a certain time, not to come all together. And people also were quite, how do you say, pissed also, because you need, both in Italy and in France, to go out during lockdown, you need to fill an auto certification. So once you filled all this paperwork to go out, you don't want to go back and come out maybe 2 hours later and fill another certification to go out. So people arrive at the store, there is a long queue, they will stay in queue, they will not be happy, our supermarket director will not be happy, and this situation is dangerous on top of all that. So on this, enter Patrick. Patrick is the director of project and organization, and is in contact with all the supermarket directors in France, and was listening to their complaints and to their demands for help to say, how can we tell people when it's best to come to the supermarket and when it's best not to come. So Patrick decided to have the lockdown version of a meeting with us. So we are the Carrefour Google Lab, so we use Google tools. So we went on a Google Meet meeting with the lab, in this case with myself and Anne, who was the product owner for this project. And he asked us to expose this problem to the lab to see if we could help with this. And this is the problem, quite simple in this formulation, you can say. We need to avoid queues, or at least manage them the best we can. And for managing these queues, we would like to have two types of prediction: number of clients for each day, so the total one, and also the affluence for each hour of the day. So during lockdown, supermarkets were open typically between 8 a.m. and 8 p.m. We want to know for each hour or each day how many people are coming. It actually is not important for them to know exactly how many people. They don't care if it's 20 or 25. They would actually like to know if the affluence is low, medium, or high compared to the rest of the time slot of the day, because they want to tell people, don't come at 11 a.m., come at 4 p.m., for example. They don't care the exact number. And the setup is, we need to predict a week in advance, because supermarket directors during a lockdown, they are already under a lot of stress. So we cannot every day send them some updated prediction. We need to have every Monday morning a prediction ready for the rest of the week. So they can look at them Monday morning and set up their process for the week. Okay, so we said, cool, we can look at that. So if you ever done machine learning, this is time series problem. You have number of people coming versus time. So easy. You have so many methods that are already done. ARIMA, Prophet, if you want to be fancy, XGBoost, RNNs, and this will make probably for a very much fancier talk, maybe a much fancier lines on my CV. But when we do data science, we need to look at the data. And we have a problem with the data because, as I said before, people changed drastically the way they shop. This is a plot of transaction. Sorry, I took away the axis for Carrefour privacy reason, but you can see the trend. So the blue bars are the transaction this year, and the line, the light blue line, is the transaction last year. So you can see in the past, like I showed in the plot at the beginning, people are really regular. So the trend is always the same. Here the lockdown starts, all the people come to the shop, and then pam. People don't want to come to the shop several times a week, so they will come much more rarely to do much bigger grocery shopping at a time, because they want to go to the shopping store once every week or once every 2 weeks. So we cannot, how can you train a neural network with 2 weeks of data? Because clearly this trend here and all the trend before is not really, it doesn't really apply here. It's really not the same type of data, not only the same volume, it's only not the same trend. Another problem is you want to make into production a XGBoost, an RNN model. You need some time. You need some time to tune the model, find the correct hyperparameter, put together your data pipeline. In this project, the lockdown is not going to last forever, and also the supermarket directors don't have weeks to wait for us to tune our models. So the model was asked, they asked us to please be ready as soon as possible, even if the model is not perfect, if it's good enough, because we really have an urgency. We need to give results. Of course, not bad results, because this can be dangerous, but good enough results fast enough. So we looked at the data a little bit more. This is like a zoom in, and actually not just the first weeks, but also during the lockdown. We noticed that in the past, when people have their work, for example, most people tend to do their shopping during the weekends or the night hours of the days, especially Friday. During a lockdown, a lot of people were working from home or not working. So what we see is that several days, actually, this is the number of people coming to the store for each time slot, and you can see that it doesn't vary so much. It's very flat, and also even if the magnitude sometimes varies a bit, the pattern, this two peak pattern is very consistent. So a lot of people like to do their shopping at 11 a.m. and between 4 and 5 p.m. And that's, as again, this is the absolute transaction. This one is the relative ones by day of the week. So you can see that compared to last year. So you can see the weekends are losing a lot. So Friday is losing minus 40% of the people going there, minus 20% on Sunday. And you can say people really love Wednesday morning and Wednesday afternoon, which increased a lot. So we say, okay, when you want to do a machine learning model, usually I find this image on the internet, you can find a very similar one. You look at the data, you analyze them, and then you train a model. You decide which model you want, and you use this data to train it. And now where the awful proposition comes in, what if you don't use any ML in this training part? So I'm actually cheating here because I'm in a ML meetup and I'm proposing not to use any ML. And actually this is the face that a lot of people in the lab or in other teams in Carrefour made when I proposed to use not ML, because we are ML people, we use ML. And so I told them, yes, okay, but if you don't have data, why not using an arithmetic average, for example? Let's see how it works. And actually, I was quite surprised when some people told me in other teams, they say, but yes, an average is really easy. We already calculate averages. And I say, okay, great, how they perform? And they replied to me, we don't know. And I was like, how you don't know? You can test them, right? And it turns out that for a lot of people, an arithmetic average is not a model, right? So it's not ML. So all this part that comes after, people don't really consider it. They use the average to look at the data. So they will average the transaction and look at them to gain some insight, but they will not think of testing them like you will test a normal machine learning model. And I say, okay, but all that comes out from this trained model is prediction. If my prediction is coming from an average, who cares? Let's say what happens when I try to test it. There is another small problem, let's say. It's, as I said, again, this model, we didn't have much time to test, and we didn't have much historical data to train off. So our train period was less than 20 days. And since we needed to put the model in production as soon as possible, I had to validate on the week that was just finishing. So I had only 4 days of validation because this was the week just after Easter. So we had Easter Monday in the middle, that is an unusable day for validation. But I couldn't say, okay, I wait 2 weeks and I do a proper validation, because that was not an option to wait 2 or 3 weeks to have a proper data set. So say, okay, let's start with this 20 days training, 4 days validation. And we consider 3 possible models, into quotes. You can do an average by hour by store. You can do an average by hour by day and store, to try to take into consideration if there is some daily pattern. And then you can do also an average hour store and put a double weight on the correct day. So you say, okay, we'll consider all days, and I will put more weight on the day that corresponds to the day I'm predicting, to try to capture some seasonality if there is any. These are my results. So as a metric, I used forecast accuracy, which again, maybe is not the best metric for this problem, because as we said, we are not interested maybe in capturing the exact number of people coming to the store. We want more to capture the level of the people, but both for, again, being fast enough and also clear enough with the business people. So I could implement, for example, some custom cross-entropy validation that takes into account that the classes are ordered. But if I go to a supermarket director and I tell them my model predicts with 82% accuracy, or I say my cross-entropy loss is this, it will be very, very difficult to explain, especially to people that are already stressed and overworked. So this metric is actually punishing us a bit, because it's more strict. It's a more strict requirement that we want. So we say, okay, it's not a big deal if we are more strict with ourselves than we should be. These are the results on the 4 days I validated my model with it, so the 3 models, and for various formats. So Carrefour has actually 3 different formats of supermarkets. There are hypermarkets, the very big ones, they're usually outside of city. Supermarkets are the medium ones, and proximity stores are really the very small stores that you find in the center of big cities. So this model was to be done for supermarkets. So I was looking mostly at the performance of supermarkets. And as we can see, the 3 models perform basically the same, 82, 81. So it's same performance. So we say, okay, let's go with the simplest model possible, average hour store. They perform the same, and they are quicker and easier to implement in a quick way. And actually, that's the architecture, the whole architecture we did. So there is no like hidden things here, and there are actually more queries. These are all views in Google Query and in Google BigQuery and real queries. There are a lot of more of them that they will need, because we take our approach with queries similar to approach we will take with code. So each query does one thing. So these queries are always 10 or 20 lines long. We don't have 300, 500 lines queries. So this query calculates the average. This query calculates the maximum. This query calculates the affluence. This query calculates the opening hours. So it's one query per one task. And also we put some attention in using views, which is not a real table, is sort of a materialized view, because Google BigQuery, it's a nice platform, but you spend money every time you do some operation on it. With the views, you can save money by using BigQuery only when you really need to use it, not using it all the time. Yeah, you will do to update a real table every day, for example. So it was a very simple architecture, but we took some care to optimize it as much as we could. And also, as I said, yes, this is the results. So every Monday we send to the store this type of plots that could be put in the store to tell people, okay, these are the opening hours and this is the predicted affluence we see for this week. And it was also sent to people as a form of a newsletter to tell them, please don't come under this hour. And each store has their own prediction, of course. So each store will have their own plots that they can send to their customer or put into the store. And as I said, I validated only on 4 days. So we also put in place some automatic monitoring of our model. So this is a screenshot of our dashboard. It updates automatically every day with the data of the day before and computes the forecast accuracy for the model in the weeks following the deployment. And actually, we were quite surprised. The performance it stayed good during the lockdown. So this red bar is 70%, and a lot of time slots were actually close to 90% forecast accuracy. We had some small problems when the forecast accuracy is actually a bit lower for the last time of the day, so around 7 p.m., 8 p.m. We took a look at that. Is because usually at the very last time of the day, there are less people going, so it's more difficult also to predict exactly. The way forecast accuracy is calculated, if you have few tickets and you miss by a few, the forecast accuracy will drop a lot. Even if you have a lot of tickets, you can be more, more forgiving on you. But we also take care to check that we were not predicting in the wrong direction. So for example, in our case, it would be really bad if we told people this hour is really empty, so please go, and then the hour is actually really full. But we checked, and actually our prediction was miscalculating the other way. So we were predicting more people that were actually there. So this is, of course, is still an error, but it's not a dangerous error. So in case we lose money, so we tell people don't come, and there is less people than they expect. So it's a good error in this kind of context. After we deployed this, we also say, okay, but let's also try some real ML just to be complete. So we tried Prophet, which is a package done by Facebook for a time series with strong seasonality. So it should capture quite well our problem. A bit of a disclaimer, again, we didn't have the time to pass days or weeks fine-tuning the model. So I suppose in this plot, we can see, for example, for the accuracy per day, that our average perform actually better than Prophet. This could actually be due to the fact that Prophet, we didn't take time to properly fine-tune all the parameters and to properly do some data cleaning. But the point, in a sense, is also this. This is the plot by hour for 1 day. Again, we can see the performance is close, and probably I could say if we passed time fine-tuning Prophet, we probably get the same performance or slightly better. But the point is, in this project, we really said we want good performance and we want to be fast and simple in production. So the point is, the average was straightforward. We didn't have to do any data cleaning, any tuning, nothing. We just averaged and sent. Prophet, it has also a good performance, and maybe we'll get better with tuning. But in this specific setup, it's not, let's say, our point to pass weeks tuning a model. Of course, as this is a very simple model, and so it's not good for everything. So this is a plot of the last days. So actually, we don't send this prediction anymore to the supermarket since the lockdown has lifted. But I still, since the infrastructure is so simple and is quite cheap, I still continue to compute the prediction of the model and to update the dashboard to monitor it. And we can see that the performance as expected is declining because people are coming back to work, they are coming back to their habits of shoppings, social distancing is relaxing a bit. And so this model right now is not useful anymore. But let's say we are quite happy because this model did its job. So his job now is, the lockdown is over, hopefully for good. And the job of his model is also over for now. But we learn a lot of things, and actually we are now working with proximity store to implement a real ML model, a powerful one with the full data outside of lockdown, to predict affluence for everyday work, because that's also one of the nice consequences of this. Store directors have seen that this tool can be useful, and now they want us to work on this even outside of lockdown. So my conclusion on this is take time to talk to the business. If they have a certain need, so in our case was a good model and fast, don't try to do, let's say, the cool thing when the simple thing works well for their needs. And that also goes into the second point. If you risk not delivering, especially when your project, like in this case, it's really, really important, the time component. Don't overcomplicate stuff, risking not delivering. And my last point that is really important is, it's true we didn't use any ML, but that doesn't mean we don't need to know ML. I think my big point, my big takeaway from this is you need to know all the state-of-the-art ML, and you need to know when not to use it, because it's the case not to use it. And of course, relevant is KCD. Thank you.
Thank you, Chiara, so much. This was fascinating talk and really impacted many people. I was really impressed how you were able to do such a good work in such a short time under huge constraints, and it's very fresh project, so it's very, very, very interesting. So we are 8:27. And we were planning to stop at 8:30, so we were running a bit of time because we had fascinating speakers. We have time for a couple of questions, so I would suggest that people who would like to ask questions to one of our speakers do so in a chat, so we can progress and take a couple of questions. Please. Write your questions and we'll take it from there. So we have many thanks to Chiara, many thanks to Valentina. Brava, brava. I'm very happy about that. And now we have a question for Chiara. Are you considering to use operations research approach to help stores managers on their advices? Chiara, would you reply?
I don't understand exactly the meaning on their advice. So it means to use operational research to predict the affluence for the future, or it's something else?
Perhaps the person, Alessandro, can unmute himself and clarify.
But the point is, I'm not a big expert of operational research in any case, so I will probably need to look more into it. To deal with store capacity. Okay, so to understand how many people can actually fit into the store, because that was one of our problems too. Yeah, I don't know if that was the question, but the problem of store capacity is a big problem, because the point is it's very difficult to estimate how many people can actually be in a store at the same time, because even if you have as a data the square meters of the store, not all stores are laid out in the same way. And actually the stores are laid out in a way that to let you stay in the store as long as possible. While during the lockdown, we want to do the exact opposite, so to have people go out of the store as fast as possible. So we had many questions, like from business people, how to estimate how many people can stay in one store and how much time they need to stay in on average. I don't know exactly operational research, but if there is some ideas on this, I'm taking it because that's one of the problems. Information from tickets. So I think there was a question on tickets. Yes, we use information on the tickets. So the cash register tickets have a timestamp. So we actually don't have TV cameras in all the parts of the store and in all the stores of Carrefour. So it's and this type of data is also quite difficult to analyze. So it's difficult actually to know how many people are in and how many people go out, even if you have a camera. So we are using cash register tickets. And yes, there is the problem that if you go to the cash registers, I don't know, at let's say 9:10, maybe you were in the store at 8:30. So yes, that's a possible problem that we didn't know exactly how to solve. I think there is a question for Valentina there.
Let's double check.
Yes, so it is a person asking the difference from between emotions and sentiments. So the sentiments, what we usually intend as sentiments, include a lot of things that are not actually emotions. Some example may be I have the sentiment to be in love with a person, or to be bored or interested to something. So these kind of sentiments, like to be in love, are not emotions in a neurophysiological way, because emotions can be located in some particular parts of the brain that are not the same of this one. And the moods and the sentiments can include much more from the cognitive part of the brain. Instead, the emotions use only this very old part, which is the same of the animals, and which can trigger and arouse an emotions that will last a very short time with respect to sentiments. I can be in love with a person for months or years, while an emotion will raise and then finish. Maybe be raised, triggered another time, but then it will finish, and it will involve a part of my brain that is very different from the sentiments.
Valentina, there is another question for you. Do you consider the Ekman model good enough for emotion detection and customer support applications, or should more advanced models be used?
I think that the Ekman model, because it has a lot of literature behind it, is for sure a good model for any application. But from a scientific point of view, I suggest to explore more complex models, because more complex models can have better results. We can explore only 6 emotions with the Ekman emotion model. So for this application, for any commercial application, that can be enough. But if we want to do more, of course, we have to be able to recognize all the various emotions, but not only the different emotion, but also the intensity of the emotion. I can be a bit angry, or I can be a lot angry, and it will be very different. Some emotional model, like the Plutchik emotional model, will take care also of the intensity.
Thank you. And we have a question for Chiara. Do you know if Google Maps applies a similar approach for showing typical affluent popular stores locations?
Yes, actually, Google Maps uses a very similar approach, well, probably not with an average, but something different. So Google uses like the check-ins in their map app, and they create a model after to predict affluence. So it's actually not in real time. And actually, we asked Google about their model, because we have a partnership with Google, And they also told us that with the lockdown, they had a lot of problems with calculating this kind of data because the people were not behaving like they used to behave. And so their model didn't have the correct data anymore. So Google actually faced the very same problem than us.
Okay, and there is another question, sort of continuation, if you look at the chat, continuation of this question about what kind of data Google has access to. Maybe you can comment on that.
Yeah, so Google has access to location data, which we don't have access to, for example. So Carrefour doesn't track people's devices. So we have access to the tickets of people. So when people are in the store and they pay at the cash register, we know the time that has been paid. We know the number of cashiers. We know how much time it took to pass the ticket, this kind of information. But one of the big problems we have is that we actually don't know, like Google does, where people are. So we don't know if people are queuing outside of our supermarket because we don't have this type of data. And actually, a lot of time Google doesn't have that either because not many people check in on Google Maps when they go grocery shopping. So that has been a big problem. That this model it's an approximation of affluence based on our data, and is not perfect, of course. But I think during the lockdown, almost all the techniques, both ours and Google, were a bit scrambled up because of the fact that people change their habits like overnight, very quickly and very drastically. I think nobody was expecting that.
Thank you so much. So I think we are drawing towards the end. I would like to thank once again our amazing speakers, Valentina and Chiara, for these very diverse and very rich presentations. For everyone, we are going to publish a Medium article, recap the summary of this meetup. So you are welcome to check, there will be slides there. And of course, you are always welcome to contact us, WiMLDS Paris, WiMLDS Milan, by any means available. And it was really great working with the Milan team. Thank you very much, Claudia and Carlotta. It was really our pleasure. It was our first joint event with Milan chapter, and I really hope we have more things in some point online or perhaps one day offline. Thanks again, and have a nice evening.